Hyperplane separation theorem. In geometry, the hyperplane separation theorem is a theorem about disjoint convex sets in n-dimensional Euclidean space. There are several rather similar versions. In one version of the theorem, if both these sets are closed and at least one of them is compact, then there is a hyperplane in between them, and even two parallel hyperplanes in between them separated by a gap. In another version, if both disjoint convex sets are open, then there is a hyperplane in between them, but not necessarily any gap. An axis which is orthogonal to a separating hyperplane is a separating axis, because the orthogonal projections of the convex bodies onto the axis are disjoint. The hyperplane separation theorem is due to Hermann Minkowski. The Hahn-Banach separation theorem generalizes the result to topological vector spaces. A related result is the supporting hyperplane theorem. In the context of support vector machines, the optimally separating hyperplane or maximum margin hyperplane is a hyperplane which separates two convex hulls of points and is equidistant from the two. Statements and proof. Converse of theorem. Note that the existence of a hyperplane that only separates two convex sets in the weak sense of both inequalities being non-strict obviously does not imply that the two sets are disjoint. Both sets could have points located on the hyperplane. Counterexamples and uniqueness. Use in collision detection. The separating axis theorem SAT says that 2. Convex objects do not overlap if there exists a line called axis onto which the two objects' projections do not overlap. SAT suggests an algorithm for testing whether two convex solids intersect or not. Regardless of dimensionality, the separating axis is always a line. For example, in 3D, the space is separated by planes, but the separating axis is perpendicular to the separating plane. The separating axis theorem can be applied for fast collision detection between polygon meshes. Each face's normal or other feature direction is used as a separating axis. Note that this yields possible separating axes, not separating lines/planes. In 3D, using face normals alone will fail to separate some edge-on-edge non-colliding cases. Additional axes consisting of the cross products of pairs of edges, one taken from each object, are required. For increased efficiency, parallel axes may be calculated as a single axis.